When we picture the future of warfare, it's easy to get distracted by visions of robotic armies taking over the battlefield. Relying on those cinematic scenarios leads investors to misallocate capital and leaves military strategists building doctrines for a reality that doesn't exist yet. The Defense Tech Maturity Matrix helps clarify this field. Exoskeletons and autonomous ground vehicles sit lower on the implementation axis, still struggling with ground operations. In contrast, autonomous drones, sensors, and AI occupy the high-impact quadrants, already deployed to change how forces operate. Advancing this physical hardware creates a specific liability. These machines generate a volume of data that can quickly become a burden for the people operating them. Modern military innovation now centers on whether we can manage the data influx created by these next-generation machines. Consider the physical hardware currently undergoing field tests. These wearable mechanical systems are designed to support human movement, reducing physical strain and increasing the load-carrying capacity of an individual soldier. However, these suits introduce a logistical burden. They require a constant power supply and heavy batteries in austere environments, all while keeping the human operator exposed to physical danger. Uncrewed hardware offers a different advantage. Autonomous vehicles can provide expansive reconnaissance coverage across a theater without risking human casualties. When these units are networked, they can perform swarming maneuvers, multiple autonomous machines communicating and coordinating their movements as a single unit. This coordination requires a secure, unbroken communications infrastructure. If that link is severed, the swarm loses its collective intelligence. As these machines operate, they generate dense, overlapping streams of environmental data. Investing in drone frames or robotic limbs without a plan for that data creates a bottleneck that slows down the very decision-making these tools were meant to accelerate. To navigate this environment, modern forces utilize multi-layered advanced sensor technology. Vehicles and drones are now equipped with thermal imaging to detect heat signatures and advanced radar to map terrain in 3 dimensions. Combining these sensors makes it difficult to remain hidden. Darkness and adverse weather no longer provide the cover they once did. This creates a new problem for the operator. One person cannot effectively monitor dozens of different sensor feeds and radar screens at the same time. Solving this hardware bottleneck requires a software filter. This is where AI-powered military systems become a requirement. AI processes that information to recognize patterns and highlight anomalies, like a camouflage target, far faster than a human looking at raw footage. These systems have limitations. AI requires significant onboard compute power and can produce algorithmic errors, making human oversight essential. The software acts as a cognitive filter. It processes a saturated environment so a commander can focus on making a decision rather than searching for information. Integrating these technologies leads to a framework called human-machine teaming. In this model, the machine is responsible for speed, endurance, sensing, and raw data processing. The human provides the judgment, ethical responsibility, and strategic context that an algorithm cannot replicate. For defense investors, the highest value lies in systems integration, the companies building the software bridge between sensors and the people who need that data. For engineers, the priority is data fusion. A mechanical drone frame is a commodity, but a system that can synthesize that drone's data into a tactical network is a strategic asset. Fully integrated force uses autonomous machines to navigate a dense, obstacle-filled forest, providing the commander with a clear, filtered view of the objective. Future success in defense depends on augmenting personnel to outpace adversaries who remain overwhelmed by their own data.